Assalamu alaikum YouTubers, welcome back to SLK Tools. Here in this section, we'll learn the material estimation just for a circular water tank. A few friends just asked the material estimation for circular water tank. That's why I'm doing this guide today now. Alright, let's just start the calculation over here. And of course, I'll do just an example, right? In this example, we are just asked to work out cement, sand, crushed stone, and of course the steel for this given water tank. Where is water tank? Let me just draw it. Okay, wait a minute. How can I draw it? Let me just think. Alright, let's go. Say this is just a plan. Alright, the diameter 4 meter, and this one upside is just 15 centimeter, and this another one, the last upside is just 10 centimeter. How will be at section? Let me just do this guy over here. This is the base and wall with base. This is the slab. Alright, and this is RCC 124 and 15 centimeter thickness, and this is of course PCC of 124, and the slab is also RCC 124 and 10 centimeter thickness. Of course there is also just like a hole over here, and the hole is just circular, right? And the diameter is just 60 centimeter. And some other things are also known, like the depth, and the steel is just 1%, and number 4 bar will be used. Also this PCC thickness is given as 10 centimeter, right? So I think these details are enough to calculate all these things, these required things, right? I'll just come straight into solutions over here. In the solution, my first approach is the PCC work. Just to look at over here at the base, we have PCC 124, alright, and this external circle just represent the PCC work, and the thickness is also given 10 centimeter. If I just calculate the area of this circle, and I'll multiply the thickness with the area, so I can get the PCC work like this guy. The area will be pi d squared divided by 4 times the thickness. I can get the PCC work, right? And this will be just in form of volume. Just little late, we'll just go in detail to calculate cement, sand, and crushed stone in the same PCC work, right? And that will be just little late, right? So plug and check in, and remember which one diameter should I plug over here in this equation? The d square, right? The diameter, just look at over here, I should plug the diameter of the external circle, right? So I'll add 15 centimeter to one side and another side, and 10 centimeter to one side and another side. This will give me the external circle diameter, which is of course 4 centimeter plus 15 and 15 centimeter, which is 30 centimeter, and 10 one side and 10 another side, so 20 centimeter. 13 plus 20 equals 15 centimeter, and 15 is just of course 0.5 meter. So 4 plus 0.5 meter is just 4.5 meter, right? So the diameter is just 4.5 meter. Alright, so pi times 4.5 square divided by 4 times the thickness. Thickness is just 10 centimeter, which means 0.1 meter, right? So when you do little mathematics with this guy, of course you can get 1.59 cubic meter. This is of course the PCC work, right, at the base. And my next approach is just the RCC work in this base and in this wall, right? And this is of course quite simple. So I can say RCC work in the wall, just right. But here is a problem. We have the base, which is over here, this one, and the walls. I'll just make these guys separately, right? Like in this palm, I'll call this guy as the segment 1, and the wall is segment 2. So I'll just calculate segment 1 estimation first over here, the volume, right? And again I'll use the same formula, pi d squared divided by 4 times the thickness. But which one diameter should I take over here? Remember, the second circle just represent this guy, the RCC, this RCC base, right? So the diameter of the second circle is just 4 plus 15 centimeter to one side and 15 centimeter to another side. 15 and 15 equals 30. So 4 plus 30 centimeter is just 4.3 meter, right? Of course. So the diameter will be just 4.3 meter. So plug and chug in, we can get, of course, pi times 4.3 square divided by 4 times the thickness is just 15 centimeter, right? And this is given. Of course, this circle make 15 centimeter just little height, no problem. This is not 5 centimeter, right? This is 15 centimeter. Alright, so times 0.15 because 15 centimeter is just 0.15 meter, right? Do a little mathematics with this guy, of course you can get 2.178 cubic meter. And this is the RCC work of this segment 1. Now the RCC work for segment 2 is quite simple, right? The segment 2 is just like just like a ring in section. Just look at this guy, right? And this is just a water tank. Alright, this is just the AutoCAD modeling, no problem. So the inside is just like a hole, like a pipe, right? So I'll just subtract in formula the inside diameter, the diameter of inside circle from external diameter. So I can get the ring area, right? Then I'll multiply the ring area with this depth. Of course, I can get its volume, right? And this is good, I think. So I can say the area will be just, and remember the diameter, the internal diameter is just 4 meter. The external will be just 4.3, right? Because 15 centimeter to one side and 15 centimeter to another side. We'll just add, right? So the formula will be just pi d1 square negative d square divided by 4 times the depth. D1 just represent this 4.3 meter, right? Which is the diameter of this second circle. And the D is, of course, just this internal diameter, right? So plug and chug in, we can get, of course, the RCC work in wall pi times D1 is just 4.3 square, negative D is 4 square divided by 4 times the depth is just 3 meter. If you do little mathematics with this, you can get 5.867 cubic meter. And of course, I think this is not much challenging, right? You can ask if you have a question and comment. You can call me too, right? No problem, we'll solve any problem, okay? And again, I can say RCC in the slab. This is also RCC slab, right? And the formula will be the same, right? Pi d squared divided by 4 times the thickness of the slab, because the slab is just circular, right? But which one diameter should I plug over here? Look at the slab is just right placed on these walls, right? And the diameter of our wall was just 4.3 meter. So the slab diameter will be also taken 4.3 meter, right? So I'll just plug 4.3 meter in this D place. So pi times 4.3 square divided by 4 times the thickness is just 0.1. Just look at our hair. It is already mentioned over here, right? RCC 124 and 10 centimeter. 10 centimeter just represent the thickness, right? So you can get 1.45 2 cubic meter as RCC work in the slab. But here we have just a hole having diameter 60 centimeter. I'll just subtract this hole, right? So I can say deduction just for this hole. And the formula will be the same because the hole is just circular, right? So pi d squared divided by 4 times the thickness. And the diameter is just 60. It means 0.6 meter. So pi times 0.6 square divided by 4 times thickness is also 0.1, which is the thickness of slab, right? So equals 0.028 2 cubic meter. This is deduction, right? So I'll just subtract this deduction from the RCC work in the slab from this 1.452, right? So subtract 0.0282 from 1.452. You can get 1.423 cubic meter. So this is of course the net volume, right? Or the net quantity of this slab, the RCC slab. Now, what will be the total RCC work? I'll just add all these guys. This one plus this one, RCC and wall, plus this one, RCC and slab. So I can get the total RCC work equals 2.178, which is RCC work in wall segment 1, plus 5.867, which is RCC work in the wall segment 2, plus the RCC work just per RCC slab, right? So add all these guys together, you can get, of course, 9.468 cubic meter, right? Now let's just calculate the steel, right? And the steel is of course number 4 bar, and it's of course at the rate of 1%, right, of all RCC volume. So it's just 1%, and to remove the percent sign we just divide this guy by 100, right? If we have 1% steel and 100 cubic meter, how much will be just in 9.468 cubic meter, which is the total RCC work. So we can get 0.09468 cubic meter steel. And the steel is just in pound of volume, right? I don't need this guy in pound of volume. I'll convert this guy into kg, right, by multiplying 7850, which is the unit weight of mild steel bar, right? And this is of course 7850 kg per cubic meter, right? So you can get of course 744 kg steel over here per this water tank. Now let's talk about the total net RCC work, right? To calculate the cement stain crust stone, right? And this will be just assumed as PCC. Say how? This is just total RCC work containing the steel, right? I'll just subtract steel from this, which is 0.09468 cubic meter steel. So I can say 9.468 negative the volume of steel, which is of course 9.373 cubic meter. And this will be just assumed as PCC, right? Because we have already deducted the steel from this RCC work. So this will be just assumed as PCC. And the total PCC work is just of course 1.59 plus this guy, 9.373. So the total PCC work is just 10.963 cubic meter. And now let's calculate cement, stain and crust stone from this PCC work. Alright, I'll just start a new page because I have not quite many rooms in this page. Alright, so the total PCC work, which is 124, equals 10.963 cubic meter. And my approach is just cement, sand and of course crust stone. For this approach, you can of course watch a nice video in the same playlist. I have already explained all these guys in this and that lecture, right? And this is just a screenshot of that lecture. I have another screenshot, this one. I have another screenshot, this one. You can of course watch that lecture first. And I of course recommend you to watch that lecture first, because that lecture contains a lot of information about PCC, right? And the material calculation for PCC. So just watch that one. I'll just go over here little quickly, right? So to calculate any material, we have a nice formula, which is the ratio of material divided by sum of ratio times dry volume. This formula will give me just the volume of any material, right? Like I can say, if I want to calculate cement, I have the ratio of cement equals 1. Just look at the ratio, it's 1 to 4. 1 just represents the ratio of cement. So it's 1 divided by sum of ratio. Where is sum of ratio? We'll just add all these three ratios, right? 1 to 4. Just look at over here. The ratio is just 1 to 4. Add all these guys, right? We can get 7. So divided by 7 times the dry volume. Now the dry volume is just little challenging over here. Let me just solve this guy over here, right? And the dry volume is just of course the wet volume times 1.54, which is of course 54% of total volume, right? So I can just plug this volume, the total PCC work volume, just over here in this equation. We can get the dry volume equals, the wet volume is just 10.963 times 1.54. We can get the dry volume equals 16.883 cubic meter. Alright, plug this guy over here in this equation. We can get, of course, 2.41 cubic meter cement. But the cement is in pound of volume. I need to convert this guy into bags, right? So I'll just divide this volume by 0.035, which is of course 68.8 bags. Why 0.035? Because 0.035 cubic meter is one cement bag volume over here in Pakistan. I don't know about all countries, right? If your country bag volume is just little different, no problem, you can use your country bag volume over here in this equation. And my next approach is just sand. I can use the same formula, but over here, I'll just show you the alternative method over here, right? Just look at the ratio. In the ratio we have 2 is the ratio of sand, which is of course, what does this 2 mean over here, right? What does it mean? Of course, it means the sand is just 2 times of cement, right? Of course, I have the volume of cement. If I multiply the volume of cement with 2, of course, I can get the sand volume, right? So 2.41 times 2 equals 4.82 cubic meter as sand. And the next thing is the bajri. And of course, this is known by crust stone, no problem, right? Over here we use the bajri world. I think the bajri world is not good over here, but no problem. This is crust stone, right? And just look at over here in this ratio. The ratio of crust stone is just 4. What does 4 mean? It means the crust stone is just 4 times of cement. So I'll just multiply the volume of cement with 4. I can get the volume of crust stone, right? So 2.41 times 4 equals 9.64 cubic meter. And this is really good, I think, right? And here is our detailed result. The cement is just 69 bags. The sand is just 4.82 cubic meter. The crust stone is just 9.64 cubic meter. And of course, the steel is just number 4 bar, which is of course 744 kg. And this is how we can just estimate the material just per circular water tank. Not only per circular water tank, right? You can use this method for any structure, no problem, okay? Alright, so the dimension may be just a little change, but the concept and the calculation method will be the same, right? And it's good, and nothing is just left. So thank you for watching. See you next time, and wassalam.